the broadcast, and good morning to everyone, and good morning to Michael. This is the weekly hangout that we do called Weekly Hangout LunarCubes, and today's date is 14/05/20, and I'm joined with my co-host Michael Riley. This is about the deep space information system that will come out of the lunar network. And good morning, Michael, and now it's go ahead and say hello.
Good afternoon, Abraham. It's good to be online with you again.
All right. Let's see. Russell Cox, I just dropped it, and probably he may join. Let's see. All right. We're going to get started with the presentation that we have for today, followed by our discussion, and viewers are encouraged to join in as well. And I'm going to share my screen, which is, go put that on the down. Share the screen. Yes. All right. Today's topic is the ground segment of the lunar network SIG. Okay. And just to capture, in the past we had several topics that we covered, so this continues with that. The objective is to finally come up with a deep space information system, and some of the targets to do is provide cloud-like services, and which will be sitting on top of a lunar web, which manages connectivity sessions. And this all come out of what we call the lunar network, which is described on the right-hand side bottom, which comprises of the space segment, communications, and ground segment. That is the ground segment that we are going to be discussing today. The ground segment includes the communication nodes on the surface, the network architecture, the regions defined, for example, like ITU, the op center that's going to be significant in these regions, and the user classification. All right. So later on, if we have time, we'll kind of carry about some preliminary peek into the services offered. On to the next slide. The idea is that we have a global reach that 24-hour time zone in the northern hemisphere and the southern hemisphere is able to reach the network. The ground stations, the ground station on land hopefully can cover about 1/3 of the sky or less. The ground station on the ocean, if we can make one, may be covering another 1/3 or so, slightly briefed in Appendix O. Perhaps the other 1/3 could be less viable or less interesting for our target audience. So we may not even worry about 1/3. When it comes to ground stations, there are several types and there are several scales. Typically, the ones which are funded for research, like the ones with NASA, European Space Association, SETI, and Stanford Research Institute, and several other universities with large budget are able to afford huge ones, and they tend to be highly specialized. Unique formats are likely, often privately operated, and there's a big budget with a specific target in mind. What we kind of would like to kind of stay focused as well as work around is the industrial professional kind, the home garage kind, and a mobile and the floating type. The industrial professional kind tend to be owned by multinational corporations, whether satellites and that type of operations, and they mostly generally operate from the geo satellites and highly asymmetric operations in terms of communication links and some sit in the polar orbits. The ones that we are generally targeting something which can be managed and it's very small private use or for lease that may be eventually happening out of hobbies, amateurs, amateur astronomers, and these class of people that we can get. Also to note, there are several types of mobile stations, and in the shipping industries, and there are many other industries that we will be able to latch on. Now that we have a ability to see the sky in the satellites that are see the satellites in the sky that are in LEO, medium Earth orbits, and geostationary orbits, and other moon orbits, these ground stations are connected to the internet. Now, we already got the basics covered needed for the lunar network on the ground segment. There are several topologies also to be considered, like interactive computer terminals accessing through direct broadcast systems and mobile communication system satellites. And there are many other hybrids that's possible. So down the line, we will be going through several of these scenarios. But we will restrict ourselves to about 3 to 5 of the models which turn out to be manageable as well as have guaranteed measurable results. Yes, the next big step that we'll be taking up, preferably Michael will address that the next week onwards, will be the deep space information system. This, after covering the overview, we will drill down into architectural development process, technical reference models, with several types of architectural views and the models of the technical architectures. In the particular view, at the bottom, you see functional view, computing view, commercial and contractual view, data management, security view, user views, and builder's view. These are all important point of view that we need to consider, and these are the type of system expertise that Michael brings to our special interest group, and he will identify appropriate expertise. And wherever applicable in the enterprise space, I may also bring additional people and the experts to have an overall solution. Another topic for the deep space information system will be to define regional operation centers. They tend to be dynamic in nature, and resource provisioning, connectivity, session management will be one of the primary responsibilities of the op center. Schedules, services, managing service list, class of service, metering of the services offered will also be part of the regional op center's responsibilities. And further, we expect a huge amount of database that will be addressed by consumers, providers, various permission lists, and node capabilities, and so on. And of course, when you talk about regional operating centers, they need to talk to the neighboring regions, which also will be covered. Sorry about that little interruption. Coming down to ground segment network architecture, I was intrigued by this document that I have not read yet, but there is a heterogeneous mission accessibility initiative that comes from the European Union. That may be something we can model around, okay, down the line. And what we hope to achieve is a fabric of heterogeneous nodes that exist in the physical and the virtual topologies, with varying types of capabilities in each node, and a delegate accessible to us. Delegate in this sense, I'm talking about the handles that the system has access to. Specialized node functionality also will be kind of classified, grouped, cataloged somewhere. The organization, the management, and extensive database of heterogeneous node characteristics, certain hierarchy for access, several views for modeling, and concurrent existence of the same node in multiple clusters, if you can manage that level of complexity. The picture on the bottom side shows typically when you kind of try to view it, it may look on one hand belonging to several cluster members, while on another hand, the way to access a specific capability may through a hierarchical method. And these are all something which we'll go to in the future. The next one we're going to do is the ground stations and the segments and the ground segment nodes, that is to say, the nodes in the ground segment. The picture in the blue shows one of the typical and the traditional model that NASA, some such operations do. With control and command handling of the satellite, this particular op center has a telemetry capability and the station interface and certain type of server and mission planning, flight dynamics, etc. When we model that, each of these may turn out to be an enterprise scale model, and the capability of those may be accessible to a variety and a number of ground segment nodes. Typically, what we hope to see on the right-hand side shows several types of small nodes, and like down the line, 10, 15 years from now, we hope to have several thousands of these small nodes and a few hundred of these big nodes that will provide the balanced support for upload satellite control systems, while plenty of opportunities as well as access points are needed on the ground for downlinks. Okay, so that's what we're hoping to achieve. Which comes down to a short list of other aspects of the ground segment we have to address, like the life cycle management, design practices, business proposition around it, mission control, like who owns it, who operates it, and how are the service provisioning obtained. And we hope to have distributed op centers in various regions, and that's going to be another interesting way of addressing, but it's going to make it extremely viable and practical. And asset management at the ground, and particularly the space segments, the multi-nature of ground stations operating in multiple time zones, and when it comes to the service units and how they are kind of metered and billed, the currency of those particular operating regions, all these are going to add up to another dimension of interesting issues. Of course, we'll find solutions. So, in order to run a 24/7 network availability and to use certain type of professional grade to deal with thousands of backyard, pardon me, I got myself lost. Essentially, now we're kind of looking at the global zoning, that the user community will be spread around the entire world, North Hemisphere, Southern Hemisphere, as well as in the water. According to ITU region code, we will follow these three color-coded ones, and the regional operating centers will be located in here. Okay. So what next? Okay. So these are generally the key things that we wanted to identify in terms of what it entails. And if I may take just a couple of more things which are like listed here as an appendix, we want to kind of bring attention to specifically what here I call the ocean segment. That's part of the ground segment, but a subsection where eventually we may be having a huge amount of coverage and relay stations to bounce off the surface. So these may operate like a communication relay, switch, or a router floating in the ocean. They augment to the ground resources on land, and we also hope to see several resources of space. That refers to balloons and LEO and suborbital. There are going to be hundreds of these small CubeSat-like infrastructure that's likely to pop up. So we'll be able to harvest some of those capabilities as a router or a switch, as well as in the space. There is this liquid robotics. A friend of mine who used to be a Java architect, if you know Dr. James Gosling. This is essentially a couple of snapshots from the YouTube presentation he gave. The link is given at the bottom. I encourage you all take a look at that. And what it is like a size of a surfboard with radio communication center, and the platform has its solar ones. And in the right-hand side, it shows a picture that it has a propulsion unit which harvests energy from the wave, and it has the ability to wander around. The only power needed is to provide power to the rudder. So it's able to be a loafing node, or it's a slow transport system from one place to another place, and it has sufficient power to do a ground station like capabilities down the line. Right now it already has, and this is a wave glider, as they call this, the spec here. And one of my challenge here is to float a communication station, and we will have a session later on down the line, preferably by James Gosling himself, to kind of help characterize the communication capability that will be suitable for our needs. And hopefully one of the work groups within our SIG will be able to provide a reference design as a communication node as well. Okay. So other than that, we should be eventually also catching up. Okay. With some garage session. That's another subject for the day. And that's about what I have to do for today. And I went a few minutes past our usual time quota. We covered ground segment with worldwide network access, and this will be continued with deep space information system, and that would be hosted by Michael Rayleigh in the next week. And
thank you, Abraham. You covered quite a bit of material there.
Thank you.
So that gives us an overview of mostly of the terrestrial component.
Yes.
One thing that strikes me is the international nature of what you're talking about. The international with the oceans, multiple different multiple communications, regulatory regimes are possible. You mentioned the European effort to coordinate their data activities across multiple missions. I'm
Yeah.
wondering what are some of the similar efforts that we have going on in the U.S. that you've come across? Also sounds like you're in a barn.
That's my phone. I was not expecting any call right now. Yeah, go ahead.
I was wondering about some, if you'd come across similar efforts or approaches from the U.S. side.
I'm not aware of that, but people who are talking about BTNs in the commercial arena, I'm almost certain guys like Vince and his buddy Dr. Lloyd Wood, he used to be in the university background and working for with oh man. I think that's an emergency was happening. Okay. So, pardon me. Dr. Lloyd Wood, who is now moved to Australia, I believe he moved into the commercial segment. And these people, I don't know which company he works for, but my guess is Telstra. They are all kind of looking towards space. So, they're looking at space. And these people have a global vision, and I think even Google with its Loon project, they are finding different ways of dealing with resources that can be tapped into. So I don't know if I directly answered your question, but what I anticipate is by the time we step into about 3 to 5 years from now, they all address the same question from different point of view, from a different niche. Mostly they're all commercial initiative. So what is in it? Okay. So
how about some of the lunar missions that are being proposed? For example, the Astrobotics and some of those folks. What have they put any effort into multi-mission interoperability?
I don't think they're doing it now because all the resources are concentrated on what they're supposed to be delivering. But when I have, from what I have had little conversations here and there, they are also having a broad vision like what we see and what we see down the line. They do have broad vision, but today I think they're kind of pressed on to deliver what they have to do. For example, I'm talking about Astrobotics and our buddies Moon Express, and to some extent even the launch service people like Moog CSA and SETI, they all have big vision. So we have to kind of work with these people and more, and particularly from the if there are any NASA initiatives and university initiatives, and get them all to percolate these vision, and it will be best that we find the right one and align with what we are able to do. It doesn't give up. Okay. Right. I'm sorry about that interruption. Like I was making alternate provisions for him not to call, and that's what he does. A contractor.
Right. I was just taking a look for the open source multi-mission software platform that Goddard Space Flight Center has put together.
Okay.
That's more on the space segment side, I believe, than on the ground segment side.
Yes, but for NASA's mission, they are focused in the 3-hour time zone, and plus they have the other resources on the ground segment specifically to tap in or to serve NASA's objectives. But what we're kind of saying is like, look what the cell phone did. It crossed the international borders with economic influences, and the way like Google's presence cannot be eliminated. AT&T's presence cannot be eliminated in countries like China and Vietnam and anywhere in the world for that matter, because they had something in hand like these, and they're able to influence the culture and how they go about communicating. What we see is something like that, the communication of humans, humanoids, and robots, and other parts of things that we see is going to be harvesting something good that's going to come out of moon surfaces and beyond. So I don't see a direct connection of a cell phone on the moon today, but you and I kind of know what this is leading to.
I see. Now, the cell phones depend upon an infrastructure. And I suppose our first version of the infrastructure, the lunar networks, that's going to be built from the excess capacity of some of these missions, the conventional missions that are going to the moon in upcoming years.
Absolutely.
There's some interesting technical questions that are associated with that. For example, how do we take advantage of inter-spacecraft communication? And I know I'm drifting away from the ground segment side here for a moment. But I suppose you have an analog in the lunar situation where you're going to have a ground segment on the moon as well, except that I don't know how many operation centers you're going to have on the moon in the first generations of our lunar networks vision. So,
yes, absolutely. Whether we're going to call the landed resources on the moon surface as a ground segment, I'm not sure. Currently, it is kind of clumped into what we call it space. Anything which is not on Earth is space. That is the current definition. But you do have a valid point that need to be kind of put in the appropriate placeholders. And
I think so.
Pointed out the other one you mentioned about spacecraft to spacecraft communication, the DARPA's project F6, the fraction system. That's an excellent model, and I do recall sitting in some of the presentation in flight software done at JPL.
Right, I think you're going to have some of the same technical issues in terms of communicating to any planetary surface from your orbital assets. That's one aspect that you're going on. But then there's the control aspect, which is another part of what we're getting at, particularly with the ground segment, because you do have your control centers, you do have the places which are trying to feed commands and data to your space assets from the folks on the ground who actually own them or wish to use them. So there's some technical issues, particularly if you're going to try to be cobbling together the network from those existing spacecraft that this is not their primary mission, it'd be their secondary mission.
Yes. Can you go and drill down to some more level of detail?
Well, what I'm thinking about is that if you have orbital communications assets going around the moon and you want to use them as big pipe communication back to the Earth, you're going to have some of the same technical communications issues, because you're going to be talking about flyovers or as spacecraft pass over, say, different ground assets, or if you have, say, different spacecraft communicating to each other. That part, when you have that sort of lunar surface to orbit communication, that's going to share some of the same properties of the communication you'd have from, say, the Earth up to Earth orbit. A big difference, though, is going to be that control issue. right now you don't have a control center on the moon. However, that's one of the main reasons that we're talking about the ground segment. That's where the control centers are. That's where the data centers are. We're talking about how you can essentially put together a ground a network on the ground that allows you that 24/7 network access as part of your first almost an interplanetary network once you talk about setting up a network connected to the moon.
Yes, and I think that's where our strength comes. If you remember the earlier evolution days that we have witnessed when the internets were kind of fragmented and to some extent the things were not quite well operable, and in the US we had the best internet to start with, and as each country was coming, it was like a hit and miss type of a thing, which was it may work if you're lucky, it may not work, all that thing. But now we have things that work with a predictable and measurable and commerciable connectivity where billions of telephone market, for example, as well as the internet market that exists today. So, as you pointed out, yes, there will be few hundred, I wouldn't say a few hundred. In my thumb rule, like I was kind of counting close to like around 60 to 70 type of connectivity in the session management models that we may have to cope up with. This classifies with where the node is located and where its ability to store and forward, its ability to immediately relay. All these kind of trickle down into a bunch of types of methods through which you can send. The equivalent I can say is like today we have USPS, FedEx, or UPS, which is able to carry a packet from one place to another place. But imagine that if you had a system that it can also route between these three methods, the latency as well as the operation does get much complex. But the latency and the end-to-end delivery and lots of optimizations of trips that are made for the delivery purposes or inter-nodal traffic, they all will be substantially reduced or like made more effective. That's the way we see when you have so many assets which is flying and they only know how to talk to the ground and only in few time zones. Now we are going to have nodes that are available several places around the Earth, including in the water. So there will be a couple of simply relays because they kind of bounce around various types of paths which may be idle or less effectively used. If you see the self-learning routers that is used in the terrestrial internet packet routing, like the Cisco does, there are millions of packets. It kind of dynamically kind of understands the characteristics of 10 different ways it can reach the endpoint and settle on one or two reliable, optimal way that it will choose to and prefer to do that. I'm saying these are the type of things that we will get into, and like I mentioned earlier, I counted something close to about 60 types of this kind of a connectivity models. So if you kind of classify them tightly and kind of limit and control who is allowed to do what type of a connectivity or session models for optimized end-to-end delivery, we'll have a very effective system. And what will be interesting is constantly some of the resources will be dropping in as available, as some of them will get disappear either due to orbital dynamics or the ground level internet connectivity problems or somebody's internet giving trouble. All these things are anticipated. But yes, that's a challenge that we're up to handle. You, Micah.
Well, it seems that there's an interesting modeling and simulation problem here. One question I have is how much should the individual nodes know about the different communications nodes that you have in the system? That JPL ring road presentation that you shared was quite interesting before. And I'm wondering just how much smarts should an individual router, if you will, have? Should each individual router be predicting when different spacecraft are going to become available, or are you going to have them be less intelligent and just sit there with their receivers open and just wait for a little bit of a downlink to know who's in the vicinity, and then make the decisions that way? There are trade-offs for both of those, and they come in pretty strongly when you talk about the amount of energy and information bandwidths that you're going to be able to support between the different nodes. For example, if you know where a spacecraft is going to be, then you can actually optimize your antenna system and your transceivers for that particular communications link. If you don't know where something is, well, then you're going to have to back off from something that might be optimized for mass, power, and information bandwidth. I have to go with something that has a much broader antenna beam, for example, and might have to pump more energy into it, or have a better receiver. So those are some trade-offs that will have some interesting effects on the configuration of the mission architecture itself, and it might even affect the answers as to whether or not you can actually put something on board a CubeSat or a Cube spacecraft, or which elements of what you're talking about can be CubeSats and which are going to have to be a more conventional or larger spacecraft.
Yes, very, very good and all valuable inputs. What I was kind of hoping is that, like, people are like the members who pool their resources into the lunar network and consider themselves as service providers of some kind. And if they are willing to share their resources for orbital relay node or some capability, all these will be available in the database which manages various forms of resources which may not be available all the time, but which may be subject to how much power is budgeted to. And this is where the operations center will shuffle around with all the flight manifests or all the where are you at this point of time?
The ephemerides.
Yeah, what do you call those things?
You can call them ephemerides. They're the ephemeris that contain the location and prediction information about where something is going to be.
Yes. With those kind of data, this can be kind of a pre-planned with one or two or more situational assessment. In case this thing doesn't happen, no big deal. At least switch around and see if we can provide you resources to be useful here. Which means, like equivalent to of little web clicks here and there we do today, there is a mechanism of metering. It's worth like 1 cent, 2 cent type of thing. When it comes to this orbital resource reutilization, these things will contribute into several thousand dollars worth of sharing resources when otherwise they go underutilized. In order to make that utilization go up, there is a lot of work to be done within the provisioning system that we will build. And do we have all the inputs for it? Definitely not. But these are the inputs that you bring valuable. They will kind of contribute into building the right type of a system. And chances are like you have the adequate system engineering background, the knowledge. We do not necessarily put these criteria and optimization in day one. We will build the ability to hold that clause and considerations down the line, and when we are comfortable and tested adequately, the system optimization is really increasing the overall return on the investment. That's when we'll slowly start introducing one optimization by other. There may be certain situations a set of optimization has to work together. That's fine. These are the way we will kind of roll into the system. Like when a enterprise model, when a company buys another company because they have a technical skill and capability, and the capability does not get rolled into the acquiring company's label brand right away, but slowly they'll make some changes to the way this larger company will want to incorporate, and that's how the end users will get to see it. So pretty much that's some enterprise model that we'll be walking into as we speak of these kind of capabilities and optimizations and provisioning systems.
So you mentioned an enterprise model. So is Russell Flexure Engineering, is he thinking in terms of putting together our own enterprise model?
I think the vision is big. We don't think we will be able to attempt all of it. But what we kind of see is there's a lot of organizations like SETI and Kennedy Space Center. They all seem to be interested in some parts of it, not necessarily all. So between what I, Russell, Pamela, you, etc., I think what we would like to influence is we have the big vision, and whatever contributions are like a support that we may be able to get from industrial and professional organizations will align with them, and what is in it for them will be somehow carved out in a way it matches their goals, so they don't have to re-engineer, but they get the skills and the expertise from our group, and in turn they support what we can do for them. So in that sense, like guys like Astrobotics and Planetary Resources, etc., they all showed very good interest in what we do. It doesn't mean they're going to change their business architectures to depend on what we do, but certain services that if we're able to enable, they certainly will be able to request us to tweak it to their specific requirement, their specific class of service, and their specific volume of traffic or whatever other criteria they may have. And if there's a commercial company like in Australia or Hong Kong or in the USA who's able to make that happen, we are happy we achieve our architectural goals. There is a commercial professional implementer that comes from somewhere else, and there is a support group like another commercial venture is able to benefit out of that. These will turn out to be our reference architectures, whether it's going to be published and publicly made available, or if the group would prefer to keep it private, it may, such architecture may still exist within our system, but not necessarily advertised for everyone to use. That's a kind of a depth and breadth. We have not fine-tuned how the organizational structure will be, but we do in a sense have an idea where we are headed to.
That's interesting that you mentioned the reference models and the enterprise architecture models. I remember that when we were working with the Prospecting Asteroid mission for NASA's Revolutionary Aerospace Systems Concepts, we that eventually became a design reference mission for NASA. And I think you've worked on several reference models or enterprise architectures in your own work before, haven't you?
Yes.
Okay, so you're quite familiar with what goes into them and how to put them together.
Yes, very much. And the flexibility within to kind of get caught up in the implementation level versus a way of using a reference like we use Wikipedia or a dictionary, but in what we kind of use them as a reference and kind of write what we want to write is the kind of a style we take. There's nobody's going to come and kick your butt. But whenever the usefulness of what comes out of Wikipedia today is something what we may turn out to be for the space industry professionals and organizations. That's one of the targets hopefully we'll be able to meet.
Right. I'm thinking that we can actually make good use of the analogy of web services and describing and integrating web services using enterprise architectures and modeling techniques. I think that's something that would be useful for us as we put together different services for the different segments that we're talking about.
Yes, absolutely. And that's why I was kind of pointing to, where was this one? I wanted to kind of share this slide back again and see. See, when we kind of drill down into these later, each of these views as well as the services that we're kind of going to be talking about, they will very well model into what is existing today in the web services that we see today. Okay. Hopefully that's what you were referring to, Michael.
I had to take care of a distraction. An alarm was about to go off, but I just took care of that. Right there, it seems to me that we might be able to make some early progress in putting together a rather low fidelity model of some of these things that we could then tie to some very simple spreadsheet-driven capability models, so that we can demonstrate, say, two sides. One would be an architectural division, an architectural description with a somewhat of a link to a quantitative model. The sort of things that people might do in a pre-phase A description of a mission. That might be something that we can do to make explicit some of what we mean in terms of an enterprise model and an enterprise architecture model, so that people could actually see an example of what we're talking about.
Yes. Okay.
And also, you mentioned before the DARPA F6 project. We developed some interesting technologies, some pretty advanced modeling technologies that we could also illustrate with some simple models for that.
Yes. And what I'm also kind of hoping that we will get to see, when the number of assets, like I was a backyard antennas, like a professional upload centers and high bandwidth communication nodes on the ground, and the increasing number of balloons and suborbitals, if you see, if they also start offering spare capacity within them to be used as a intermediary mailman, we are able to tap into phenomenal amount of resources. And if we had kind of come across some of the experiments with which was done in DTN, the delay and disturbance tolerance networking,
right,
of the data mule concept of the random patterns of all these mules going from one place to another place. They carry a lot of data which is useful and sent from one consumer to another consumer, and the mules had no idea they were providing a service. So that kind of a nodal definitions we also want to kind of put in as an optional capability to be sitting in. So I would also highly encourage that we share the, I have not thoroughly drilled down into the DTN protocols and capabilities of what can sit inside the node, but I would kind of appreciate if we had a time to spend some time, please do that, and let's kind of cross-check our understandings. And that, when it is added to these dark path architectures and other known successful models, is going to phenomenally increase the point-to-point payload carrying capacity in so many different ways that we have not seen in the space community yet, but we have seen substantially between the spontaneous networking using Wi-Fi, and there's also another type of a networking and data mule capability going through what is it? There's one more type of a spontaneous network. The word doesn't come to me. Not necessarily Bluetooth, but that's yet one more. So even without internet connectivity, the friends moving with friend circle and the friends going to friends, like how LinkedIn is able to find the connections. This particular product I'm talking about is able to find the connection and deliver the end result of somebody is looking for somebody. And what I was surprised to see, there's one or two reports in YouTube somewhere. They found they thought a person was missing, but they kind of went to some other country and somehow lost a contact totally to finally consider they're totally missing. But through this kind of a spontaneous network, they finally identified they're doing fine, excepting they had lost the means of communicating back. So I see that happening a lot in the space environment. So we got quite a lot of interesting package of solutions down the line.
Well, I think to answer some of the questions about the value that will be provided by some of these architectures and capabilities that are coming online, we're going to have to start to be a little careful about how we define and analyze the scenarios, so that we talk about, so that we understand what we're talking about, that we have an idea about what sorts of nodes that we're talking about, what sorts of missions that we're talking about, and start to populate those so that we can answer those questions again about the value that we're going to be providing and the value that you would have by synthesizing services from these multiple assets. So that's, we're pretty rapidly getting to the stage where it's going to make sense to start talking about, well, what's the sort of model that you want to put together? What is that implementation going to look like? What sort of schema are you going to use to put together the model? Are you going to be drawing, what are the sorts of modeling tools are going to be available to you? For example, spreadsheet-driven things versus more technical models, computer models, other kinds of simulations. So those are some things that we're going to have to be laying out, just as you would for any sort of preliminary analysis that you would have in the conceptualization stages of any mission or system.
Yeah, you're absolutely right, and that's why I want to spend adequate time with you and Russell, that we can understand generally the scope of several things that we're talking about, and that doesn't mean we're not going to take upon the mission to implement every piece of it.
Sure.
And, so what makes sense and which sponsors are particularly interested in which aspects. So we have to kind of balance between our SIG's role or SIG's ability to sustain WeeklyHanout ability to invite professionals who can additionally provide solution to somebody who's supporting us. So yes, it's going to be very interesting, and I'm glad that people like you are in the team who can kind of bring phenomenal amount of expertise relevant in this picture.
No, that sounds good. So for our next hangout, that's going to be next week, the day after Memorial Day, we're going to be talking about the deep space information segment and what that means to us, and perhaps we should get into some of the modeling needs. What sort of questions are we going to try to answer, and the vision for how we're going to achieve some of those in-orbit capabilities.
Yes, it's yeah, that's a very good place to start, and you can kind of pick any order you want, because like overall, you will also have to kind of go through several rounds to cover segment by segment by segment within the architecturals and implementation part, and what makes sense in terms of business and what is already done and ready for you consumption versus what needs to be created. All these parameters will kind of start bringing their own weightage to the criteria for us to consider on the table. So you're absolutely right. Go for it.
All right, all right. So we have a target for next Tuesday.
Yes, and I would say even a couple of more. If you have, I'm quite sure by the time you kind of prepare yourself, it may stretch into a couple of more hangouts that needs to kind of come from you. But
Sure.
If you want to kind of spread it out, I'll kind of jump into some of the other agenda that I have for things like the ocean modeling and backyard communication node and all that I can cover up. But it's now going to be more leaning on the deep space information system catching up.
That's right. Sounds good.
All right, Michael, I enjoy more and more of what we do. And
It's getting very interesting.
yes. And where is it? I was just going to, yeah. All right. So it's almost getting close to the end of the hour, and shall we say goodbye for this weekend, and we'll catch up on the next weekend coming Tuesday.
Tuesday the 27th.
Yeah, and that's not a holiday, isn't it?
Not the Tuesday, but the Monday is.
Okay, so good. We'll be back on track.
Very good.
All right. Bye for now.
Okay.